Hey friends, this is the third EAGE newsletter that is designed to help geoscientists find curated online courses, books, open source code, research papers, open datasets, and anything else interesting in AI/ML in geospace. The newsletter is put together by an incredible team from industry and academia. We strive to help geoscientists identify the pieces relevant to them in this big AI universe. My name is Ruslan. I am the CTO at a software company. You can read the newsletter on the EAGE's website and LinkedIn, or you can watch a video version of the newsletter on this channel. Today I'm covering the third AI newsletter for March 2022. Let's get to the content. And the first one is the book Probabilistic Machine Learning by Kevin Murphy. Probabilistic machine learning covers all the technical and practical aspects of modern and classical machine learning. The book content includes a significant portion on probability theory and linear algebra, which are key ideas for understanding and developing modern machine learning systems. Aside from the fundamentals, the authors present in-depth insights and explanation into recent breakthroughs in supervised and unsupervised learning. This book has the potential to be the most comprehensive work on machine learning available today. The book provides practitioners and beginners to the field of machine learning with a thorough overview of machine learning theory, from fundamental machine learning algorithms like random forests to current state-of-the-art natural language processing and graph neural networks. The book covers it all. The accompanying code allows you to jump right into the material and is offered as a Google Colab link, so that you can start working with an implementation in your browser right away. And the next one is the news: Machine Learning for Fusion Reactor Control. Researchers at Plasma Center, in cooperation with Google DeepMind, have integrated machine learning models into real-world fusion reactor experiments. They combine a neural network that has been trained on simulations with actual reactor hardware. Long-term plasma stability is the major difficulty in fusion research. They demonstrated that the model can generate longer fusion sequences. The neural network discovered previously unrecognized plasma configurations. The study focuses on breakthroughs in physics combined with machine learning, which enable innovative insights and experimental results that were previously unattainable. As such, this work can be used to understand which techniques to use and how to apply them in real-world, large-scale scientific experiments. By the way, if you like what you've seen so far, be sure to smash that like button so the video can reach more people. It is much appreciated. And the next one is the interview with Andrew. The AI pioneer was instrumental in the creation of enormous deep learning models based on massive amounts of data. But Andrew argues that it's time for smart-sized, data-centric solution to enormous problems in a recent publication published on EE Spectrum. Deep learning networks have been advanced dramatically over the last decade, to the point where the code, the neural network architecture, is essentially a solved problem for many applications. It is currently more productive to leave the neural network design alone and focus on ways to improve the data. Here we have next Datathon. A Datathon was held in mid-2021 to explore how to repurpose oil wells for geothermal energy production. Various teams collaborated to determine how to prospect for existing oil wells that may be repurposed. The event was called a Datathon rather than a hackathon, since each team used the same dataset to address the same problem. There was one team, led by Nabil Mohammadi. They use machine learning to forecast bottom hole temperature from a variety of wells data in order to identify old wells with the best heat flow. He has provided a summary which is linked below. Energy demands are becoming increasingly important, and community gathering like this Datathon are one way to brainstorm the solutions. The teams are fairly diverse, which lends itself to creative thinking. Yet, the team also tackled the problem with new technology solutions for the industry. The code and work from this Datathon are public. allowing anyone to pick up the concept and work on them further. And the last one is the paper. Centimeter scale lithology and facies prediction in cored wells using machine learning. Researchers from the Colorado School of Mines propose unlocking warehouses full of high-resolution data by utilizing machine learning methods for automatic lithology and facies prediction for core data. Traditional well-log data cannot resolve fine scale below 5 cm change in lithology, preventing well logs data from fully characterizing the subsurface. And there is also an alternative way. The core is true to geologic scale and heterogeneity, and assisting in resolving fine-scale changes in lithology. The geologic core, primarily gathered during drilling for hydrocarbon exploration and development, is costly to collect and store, and is typically underutilized due to its analog nature. The researchers propose the outputs that are fully digital, allowing them to be used for reservoir model parameterization, basin-wide mapping of core lithology, and other applications where fine-grained information would provide novel insights into the subsurface. The code for this study, as well as all the experiments, have been published to GitHub. If you know any useful resources for geoscientists, then reach out to me in the comment section. All recommendations will be considered for future newsletters. And before you go, consider checking out our previous newsletter, where you might find something interesting or useful there. Thanks for watching and see you at the next one.